All right, everybody, it is Friday, so I'm told, because days have lost all meaning at this point. January 15th, and we are hard at work. Today, for an update, I wanted to go ahead and do a deep dive on some of these parts and kind of show you just what it takes to create the world's first electric jet kayak. But before we get into that, got something exciting to show you. This little box came up a couple weeks ago. So we've been talking about how ridiculously efficient the FluxJet kayak is, right? So here's the question. If you were to take a power tool battery and an adapter cable and connect them together and plug it into the kayak, how far could you go? Find out soon. That's our next video. So leave in the comments below, how far do you think you could make it on a 5 amp hour DeWalt battery in a FluxJet kayak? Leave your comments below. All right. Down to business. Today, what I want to walk you through is kind of what it takes to make the FluxJet kayak possible. Because it doesn't just happen overnight, and it doesn't just go from 0 to 100. It's a progression of things. And the kayak itself is one piece, but there's a whole bunch of pieces that all have to come together to be able to make the FluxJet kayak do what it does. So the first thing I want to show you is kind of the progression. So when we make our first iteration of something, it's usually a 3D printed facsimile, not necessarily a functional part, but something that allows us to test fit and see fit and function. Does this thing fit in other thing? And be able to get a rough idea if we're in the ballpark of the part we're looking for. So then we'll revise and we'll revise. And then eventually you get to something that is an actual testable prototype. So this took about 20 hours to print. Not very strong, but it allowed us to test fit things. This one was actually functional, and we used it for several months in testing to test the fluid dynamics and test the weedless and all that kind of stuff. But this prototype cost somewhere in the $350 to manufacture. This whole thing was machined out of a solid block of plastic. So completely not practical for production. And then eventually, if you work really hard, you end up with something like this. So this is an absolute piece of artwork where not only is it functional, tested, but it also has DFM, which is called Design for Manufacture. And that's where it gets really hard. So it's taking a piece that works and then figuring out how to make that pop out of a mold in 30 seconds for a couple of dollars. So obviously there's a huge amount of upfront cost that goes into all the molds that go into this thing. There's a giant steel clamshell that this thing goes into that's injected with plastic to make this part, but now we can make this in 30 seconds. So it's that process for each one of these parts, and I'm going to kind of walk you through some of the progression on some of these different things. Here's another one. I'm going to do the Julia Childs for you today. So you can see here's the original steering assembly. So you can see that the steering bucket was all 3D printed rubber, and then there's a bushing 3D printed carbon fiber tube. Then you have your turntable up on top, and then that is what is your steering mechanism. So skip forward here, and now you can see you've got your lovely injection molded turntable, still with your carbon fiber shaft, and then eventually you end up with the real deal with your fully injected palm bushing here that interfaces to the kayak, your injection molded turntable, and your injection molded rubber nozzle. And then on top, of course, you have your CNC carbon fiber plate for all the early pre-orders. And one of the neat things that we did on this that we're recently finding out no one else does, our steering line is just one piece. So there's no tying lines together because each one of the pedals in the FluxJet kayak has an adjustment knob so you can adjust the line length. So what we did was make it to where the line just wraps right in this little channel. So you just wrap the string around inside that channel. Then there's a gasket that goes on top. And then when you bolt that plate on, that compresses the line in there. So you just have one continuous cable. So you don't ever have to worry about a knot coming undone or something breaking because it's just one line that goes all the way through. So here's another one. You start out with a 3D printed handle. Try to get the fit and feel right. Then you have a base piece that goes on there, which is the mounting section. And then eventually you go to an actual manufactured part where now it has the full feature set. It has the ball detent. There's a little stainless steel ball in there. And those two pieces made together like so. And it's things like, you know, the testing on this. So once we got to this part, you'd think we're done, but we weren't. So we tested for months and months and months, and what we found is as the ball would roll inside, there's a little detent pocket that it would drop into, and over time it was kind of wearing that little pocket out. So one of the things we just recently changed was actually going back in and adding a little brass insert on the handle side, so when that ball rolls back and forth, it has a hard detent to click into, so you get a little better handle feel, it holds center a little bit better. Just little stuff like that that makes all the difference long-term on the quality and function of the product we're building. And then the final stages of this are actually, there's a whole PCB integration that goes into this, a custom cord set, all the tiny, tiny little details that it makes something that looks really simple actually work in practice and work in the ocean and work in all kinds of horrible environments and all sorts of different things. So there's another one, just the kill switch. Something as simple as your kill switch starts out as just a little 3D printed test part, and then eventually you end up with an actual manufactured piece with a custom cord set. And that guy just installs into the kayak, and your magnet goes on there, and that turns the kayak on. There we have one of the original ride plates. You can see that that's been put through some stuff. This started out as just a block of plastic. We put it in the machine, machined out this plate with the fins, did some weight removal on it. This went through 4 or 5 different revisions, and eventually you end up with, ta-da, injection molded parts. So you can see we've pocketed this all out to make it lighter. You also see one of the cool things we did was when we put these pockets in, we realized that this plate sits upside down so water would pool in it. So we actually put tiny little drain valves in each one of the pockets just to make sure the water would drain out of this thing and not pool up on you. So when you pull it out of the water, you don't want to tip it and all of a sudden have water douche out onto your feet type of thing. So that's the level of detail that we put into trying to make sure that we think of absolutely everything as we go through all of these parts. Here's another one we're a little obsessive about. So the 360 light has become the love of my life, I swear. You'd think this would be a very simple project, right? Well, it turns out it's gone through a lot of different iterations. So it started out as this short, fairly large tube. It was pretty ugly. This was the actual one that was on the kayak at ICAST. 3D printed top and bottom, then you had a carbon fiber tube, and we're actually using the same mount. It's just a GoPro mount. So you can actually use that to pretty much mount anything you want. We figured that would be a nice, easy way because this thing is so light. It's basically just a boom for a GoPro pole. So we figured that would be a nice, easy way to do it. So then we went to the second version. We made it a little longer. Now it's got a nice billet base on it. Still has a better 3D printed top and bottom section, but still not quite there. And then we arrive at the final. So now we have we've extended the lead on this a little bit because we actually moved the connection port for this down inside of the tank well now, because we realized that when we strap the kayak down, sometimes the strap ends up running right by where that was. And when we stacked the kayaks, there was a potential of the next kayak being able to damage that port on the top. And we also realized that with it standing up straight, there's a potential for water to pool in it. So we moved that down horizontally now, just right down below inside of the tank well for this to connect to. And you can see now this actually has a fully injection molded lens, injection molded base, the LED in there. But here's the kind of thing we run into. So here's the struggles of manufacturing. So we finally get the part, hooray. But if you look real close, you'll see there's little defects and stuff in there. You can see there's little bubbles and just weird stuff going on. That's just kind of first run parts. And through the magic of editing, cut to new part. So you can see on the second round, we had to make a few little adjustments to the way that the mold came apart, but now they run perfect. So it's just kind of, you have to run the parts to get the machines that build the machine to all work correctly, as well as the kayak itself. Let's check out the box. So this is a cool one. Went with a NOCO box. So this is, again, an off-the-shelf box that you can get pretty much anywhere. I'm pretty sure Bass Pro Shop sells this. We worked with the guys at NOCO, and they designed, I was going to design a custom box because this is obviously what I do. I just have to over-engineer everything. But it turns out the guys at NOCO are as crazy as I am, and they over-engineered this box to the hilt. I got to tell you, they really did a great job on this thing. and I'm proud to have it in the boat. You'll see in here, it comes with this little divider panel. So if you're using a smaller, it goes up to group 31. So if you're 31, you'll put it all the way to the right side here. Anything smaller than that, you can just basically incrementally move this down to reduce the battery size if you're using a smaller battery. This box will come fully rigged like this. So as you see it, this is how it comes. So it'll come with, this is an older one. So this one had a 70 amp hour breaker in it for testing, but yours will come with a 50. And then it's got that non-proprietary connector there, 8-gauge wire throughout. So basically all you're gonna do is take that ground lead, connect to ground, and you're gonna take the positive lead from the breaker, connect those to your battery, and then plug your cable into your boat. That's it. So we've gone through and tried to systematically solve every problem before you ever get there. Let's keep going since we're on the electrical. All right, now, this may not look like much, but I gotta tell you, the amount of work that we have put into this tiny little bundle of joy right here is pretty wild, okay? So I feel it's justified. This thing is real deal carbon fiber, by the way. It's not a facade, it's not fiberglass, no, it is solid carbon fiber. And this thing is really pretty fantastic because this right here is your entire electrical system for the kayak is built down into this. Like, let that sink in for a second. You've got your programmable battery meter here that you can program for any different voltage battery, any different chemistry of battery. Then you've got your phone charger, USB-C, USB standard, and then you've got your nav lights and your internal lights on buttons right on here. And then on the back side, you have the mount for your panel is actually your bus bar. So under this cover is where you access the screws if you want to connect accessories, that type of stuff. We'll be making some videos to show you exactly how you connect to this. But basically there's just 4 terminals in here with wires on them. And if you want to connect your accessories directly to the 12 volt, you take this cover off, connect 2 ring terminals, and you're good to go. And then down below here, you see that's the actual voltage regulator, which will down convert anything from 17 volts to 60 volts down to 12 volts for you. So this is what allows us to give you that one battery experience to power all your GoPros, your phone charger, all that kind of stuff, all off one battery. So this was a big deal. Now there's one more little cable here. You might be wondering what that little guy is. Doesn't look like much, but let me tell you, this was about 2 months of my life, right? So check this out. When we first built the kayaks that you saw that were at ICAST, those had wires run all over the place, right? So you got to run a wire to each one of those lights all over the place, and then you got a 360 power port, and you got cables just strewn all over the place. It was real obvious that was not going to be a workable solution for mass manufacturing this thing. So enter this little beauty. This is a one-piece IP68 rated waterproof cable harness for the whole kayak. Yeah. Let that sink in for a second. Basically, this one cable is distributed throughout the kayak and everything just snaps right into these connectors and that's it. That's everything. It's all done. It's all waterproof. If you need to replace a light or something happens, you literally just unplug it, snap a new one in, and that's it. It's all done. So this is why we are not cutting corners and we are going so hard to try to make sure that this thing not only can be built very efficiently and serviced efficiently, but really doing things the right way and really just stepping back from the industry and going, I don't care how anyone's ever done it before, what's the best way we can possibly do it? This is the best way I can come up with to do this thing. And I know it's just a cable, but I get excited about weird stuff. So this thing is pretty awesome. We're excited about it because let me tell you, it makes it a heck of a lot easier to install these things and get a boat wired. So a couple of those. How crazy are we? We are make your own gaskets crazy. That's right. We are making our own gaskets in-house. Why? Because we're crazy people and that's what we do. I'll go one crazier. How about track nuts? You ever seen this? This is a standard one, right? Okay. Now check this guy out. Check that out. Which one do you think is stronger? So the crazy thing is our boats come with all metric. Everything was built for metric. So these will actually work in the track, but not very well. So if you got something like a long boom pole or something, I wouldn't recommend it because they're a little flimsy. The good news is the tracks that are in the boat are actually bigger than standard tracks and they're heavy duty aluminum. So what you need, and no one else has ever made before, is a track nut, specifically the size to fit these oversized tracks, but it has a 1/4-20 hole in it. So all the other track nuts you can currently get are metric. We're now, guess what, making track nuts because this is what we have to do things correctly. So yes, these will work, but if you want the heavy duty chonky ones, that is in the works as well. Speaking of things that we are working on, we've talked about this before. You've probably seen this guy. It is a block off plate, which allows you to take out a rod holder and make it a mount point. You can see there we have our Yak Attack lock and load base on there. Pretty awesome. This thing's made out of glass-filled ABS, but we may end up machining these out of UHMW or something along those lines. But this thing has proved to be incredibly awesome. If you saw the video where we're out testing speeds, that fish finder is mounted on one of these guys and a rod delete. Pretty awesome. So then we realized it turns out people hate to drill holes in kayaks. So to that end, introducing our latest patent, ladies and gentlemen. This is the cable pass-through gasket. So essentially what this allows us to do is to stack this underneath the block-off plate. And simple ideas, but basically what we have here is channels in different directions. So if you want to pass a cable from your fish finder down into the kayak, you simply just cut out this little wall right here, and then you can lay your cable right in that track. If you look closely in that video where we're testing speed, you'll see where we're actually testing this all the way back then. So we're working right now to get this part manufactured. Obviously this one's a little clumsy and 3D printed, but it totally works. So pretty exciting, because the idea was, okay, we started out with the plate and then we added the cable pass-through gasket, so now you don't have to drill any holes to be able to pass the cable through and then just down your rod holder hole. And then we thought about it further and we realized, what if we just modified this a little bit and made it to where you could use it with an existing rod holder as well? So now all of a sudden what we've done is we've added that same gasket and modified it to where it'll fit on a rod holder. So now anywhere you have one of these rod holders, you now have locations to pass a wire right down alongside the tube into the hull without having to drill a new hole into the hull. Then we get to the meat and potatoes, okay? This right here represents a lot of years of my life, right? If the FluxJet had a flux capacitor, this would be it. This is the thing that allows the FluxJet drive to be possible. So you can see here, this is what we've been working with. So this is the one of the 3D printed stator sections for the jet drive. And this takes about 30 hours to print. And it's not great. It is 3D printed, in fact. So all of the testing we've done has been worst case scenario, and we do that on purpose because we could have machined a perfect one of these out of a billet chunk of ABS or out of, you know, some high performance material, but the problem is that has the potential of being higher quality than the real part, so you never want to do that. You always want to test things less than what your true capability will be. That way you can be sure that it will work in the end when you actually get the real part. This is going to be sleeping under my pillow with me for the next few months after the absolute torture test that this thing has been to design. Just to give you a little context, I know it just looks like a piece of plastic, but this thing right here, the tool that makes this, let this sink in, cost almost as much as the tool to make the entire kayak. So it's pretty insane what it took to make this thing just kerchunk out of a mold and drop onto a plate and into your kayak. But these are the very first ones. They actually came in today, and so far they are looking fantastic. I mean, it is a wild difference going from testing with this thing to getting this in there and being able to do the real deal test. So super excited about that thing. Here you can see a little more. So here's one of the old printed ones we were working with. You can kind of see, looks sort of like the real deal. And then next to that, let's go in with, check out that guy. There we go. So yeah, I mean, such a night and day difference going from, you know, very slow, very time consuming, very non-surface finished to a full injection molded, mass producible part. And it is, that last 1% is about 90% is what it boils down to. Getting this thing to not only be manufacturable, but to get the part to run straight and true and to be able to just pop those things out and mass produce them. Pretty wild stuff, but we finally have it. Here you can see, here's the front section separated. You start out same idea, starts out 3D printed and you end up with injection molded. And even you wouldn't think these little side spacer pieces would be too much of a hassle, right? I thought those would be pretty easy. But it turns out that when you can't make anything straight in an injection mold, you have to add draft angle to it. So everything has to be a little bit bent. So we needed just straight spacer pieces. So you go with an extrusion. I thought this would be a pretty simple solution. So basically these little pieces here start out as a long extruded piece of plastic, kind of like a Play-Doh Fun Factory extrusion. Turns out these are actually really hard to get, and it was a whole thing. I thought I'd be able to keep this one domestic. I went to a company in Reno and tried to work with them. It was nothing doing. It turned into a whole process just trying to get this one little piece to make these little spacers. But in the end, what you end up with is just a super solid, super inexpensive to produce, mass manufacturable, easy to service. So that's a look at some of the smaller pieces. As you can see behind me, there's a whole bunch of kayaks. So the great news is we've gone through and we've already prepped and tested. All of the kayaks are already trimmed out and ready to go for January and February right now, which is awesome. They're ready to just drop all the parts in. So that's great. And we had the time to actually go through, and what we realized when we cut out all the holes on them, that we were finding that the steering lines inside of the kayaks sometimes were getting routed in different paths. As the tubes were going through the kayaks, they were going different paths, and that was dramatically affecting how much resistance it took to steer the kayak. So we went through every single one and QC'd them all out and realized, oh yeah, we need to figure out the absolute best path for these cable routes to go. And when we did that and went back through every kayak and rerouted every single line in every one of them, let me tell you, it made a huge difference to the way the kayak feels in the pedals. It's so free now. I mean, it probably reduced the amount of pressure on the pedals by half at least on the kayaks that had some of the weirder routes. But it was just inconsistency between kayaks. So it's just another one of those things that we found ahead of time, and we've already gone through and corrected it. We've updated the manufacturing process to make sure that they're all going to be routed exactly the same way. But it's one of those things. I don't get concerned unless I don't find a problem. Because it doesn't mean it doesn't exist, it just means you haven't found it yet. So finding that and getting that sorted out, it's a big, big win. So exciting stuff. Parts are here. There's still a few more things we're working through to get, lenses dialed in and little bits and pieces here, but for the most part, it's all systems go. We're cranking ahead, and we'll keep you up to date as we get to the finish line. Stay tuned. Thank you. We'll talk soon.